Hi, everybody. I'm a new face here. Hopefully, you'll all start recognizing me. My name's Greg. I'm one of the developer evangelists here at IBM. And I've been around quite a while, as you can tell by the white hair. But this is going to be a pretty fun session here. We're going to talk about Internet of Things, which is everybody's favorite thing, because that's what makes our lives a lot of fun. All kinds of fun home automation. You know, maybe if you're listening, have the volume up too loud and I say some Alexa command, I'll screw your house up. And that's also kind of fun too. With me today, and I'm really excited about this. This is Ishu. He's from Red Hat, so great friend of ours. A lot of great technology there we want to talk about. We're going to take a look at today. And Ishu, so tell us about yourself a little bit.
Sure. Ishu Verma. I am tech evangelist at Red Hat, and I primarily work on emerging tech topics like IoT we're talking about, and edge computing. So it's
edge computing is pretty hot. That's some cool stuff too.
Right.
And actually, IoT sort of blends some of that together nowadays, right? When we're talking about either factory automation or high performance systems,
right,
you've got to make some decisions out on the edge because there's not enough time to go all the way back to the cloud and do work there and come back, right?
Right. Edge computing is interesting because from IoT perspective, that's exactly what you want: decision close to the source of the data, so at the premise. But edge computing is also a term that's used by different, right? When networking guys are talking about edge computing, their idea is anything out of their core. So they may still be running huge data center-like apparatus, virtual CEO, right? A central office, but they think that is an edge because for them it's not the center of the edge. It's it's edge of their network. Right?
And I don't think there's even some people that have a big warehouse full of PCs and they're like, that can be an edge computer too.
That's right. And exactly, like you have small, the remote office, branch office concept where you're saying, storage is local, you have processing local, and it can work offline. So there is that where you have, a rack full of systems.
So why would we do edge? So why would you put stuff on the edge? It seems like there was this big push, everything goes on the cloud, and now it's sort of pinballing back, pendulum's coming back. So
it is.
What's the reason for it?
I think there are, one is obviously, it goes one way or the other, but I think there are some key use cases and technology trends happening. You are seeing a lot of data being generated, right? So, I mean, obviously...
just gigabytes coming off of cars and airplanes and all kinds of stuff.
I mean, the factories generate like hundreds of gigabytes of data in a day, right? So it's a huge amount of data. Other are applications. When you talk about, augmented reality, virtual reality applications, these are generating like new applications which haven't been there before. And latency is a big factor for them, right? So you cannot have data travel to some site far off and then come back and have the experience you feel where you have moved your hand and you want a response, right?
You can get really sick if your VR system isn't fast enough. That's happened to me. And the other thing I think you see is if you're trying to do process control or some kind of action reaction stuff, you've got to be within milliseconds. You can't wait for stuff to bounce off a satellite, get all the way to your data center, and it thinks about it a while and it bounces back, right?
And you talked about you worked in the embedded system before. I mean, that's where you have real hard time requirements, right? Real time.
Otherwise things can go out of control and you lose it. You lose control of it. That's not good either.
That's right. Yep.
I think the other thing that's useful in Edge, and this is maybe some ideas that we were kicking around even at IBM before we met you guys, the stuff around, you might have some analytics that do run in your data center, and it notices an anomaly of something that's going on out in the process on the far end, and you may want to send commands down or send extra algorithms down to the edge to do additional processing. Because normally you may not want to ship all that data back. It may be expensive. Right. There's a lot of data. You're trying to run down maybe a small pipeline because it's on a LTE connection or something like that, right?
Yes. Other similar vein for the analytics, we have seen the model training being done on the central side, right? So in the cloud, and then you have these models that have certain parameters, and you deploy these runtimes at the edge, and so they can actually, and then constantly as the data gets updated, you can update these runtime libraries to reflect the new trends. But those reactions are happening instantly on the edge versus going back. But the training obviously helps.
That's true. And I can see that happening for a lot of. There's tons of different reasons you want to do that, and some of it is just it's cheaper, right? Some of it's just your telecommunication costs. Is one big. Or if you've got dozens of these sites out there that you're monitoring, like. Either telcos or power companies or someone like that, or water, you're monitoring a bunch of water flow down a river or any of those kinds of things, right? There's just so much data, you don't want to send it all back.
Right, and a lot of this data is redundant, right? I mean, it's not that. So you only you want to see when something changes, right? With some some parameters, right? Otherwise, it's the same. Everything is good. Everything is good. Everything is good. You don't want to send this data.
You're like, I'm good. I'm good. Yeah, you know what keeps. You know, it was funny. We did a hackathon. It's been a couple years ago, and we were at an automated building, and the people that were the building owners thought it would have been really cool to give us access to the live building data, right?
Yeah.
But we were like, well, that's really boring because the building's not doing anything.
Exactly.
So we finally had to. You know, we recorded some of it and then we faked it by putting a bunch of failures in there, right?
Right.
It's like no, there's not much fun there. So you're right. I think then the other trick, and maybe that's part of the data science as well as domain experts, is around what do you monitor and what is interesting. Because as an engineer, I'd say, well, all the data is interesting. I want to see it all.
Right.
So how do you decide? Is there tricks to that? Or?
So what we probably if we have time, I can share some of the like labs we have done at like the early Red Hat Summit sessions. Is that you probably want to capture some metadata, right? So you may want to have a window that, hey, if sensor is sending every second, every millisecond, maybe every 5 minutes, if the data hasn't changed, you send the min, max, average kind of values with the caveat that if something has changed, then you send the whole set, right? So the window has to keep moving. It has to be sliding window. It's smart enough that it can adjust that if something has changed within these parameters, then somebody may want to see all the data, hey, how the machine started behaving badly instead of just, those averages, right? So I think it has to be very dynamic.
And I guess it depends too on what you're monitoring,
Right.
because if there's a machine that gets away from you too fast, you've got to be able to detect those trends a little quicker, like maybe bearings, vibration in bearings, or some other kind of wear indicators that it's not like instantaneous where you've got to shut it down right away, but you need to know about it within a few minutes anyway, right?
And it has to be, as you said, intelligent in the sense that what are you tracking? Is it a mission critical? Is the machine, or is it just a sensor that is just sending data and it's not going to change if it,
just like room temperature, building temperature.
Right.
Or
if it misses few values, it's not going to really make a huge difference if it's just the room temperature, right?
Right. Very cool. So what are the kinds of things then that Red Hat, what do you do and what kinds of offerings do you have to help people sort of manage this challenge of way out on the edge, things towards the middle? How do you orchestrate all of that? What kinds of things do you have?
Yeah, so for Red Hat, I think a lot of opportunities or customers we are seeing are people who are either using Red Hat in the enterprise, right? And they're saying, hey, I have this IoT project I'm starting. How do, instead of using very focused IoT applications or tools for IoT instead, how do I leverage my skill set and enterprise tools and apply them to IoT? So there's one set of those opportunities there. They're already using. They
already know Red Hat and Red Hat Enterprise. So how can we just
extend it to the
put it down on small pieces or put it out on the edge or whatever you do? Okay,
that's right. So there's one set of that. Others are customers who are using more, vendor proprietary solutions, are looking at open source as a way for them to become, more open in terms of or more nimble in terms of moving from not being locked to vendor lock-in solution, right? So they are looking at open source first, and then as they become familiar, and some of these are participating in communities upstream, so then we get to see these vendors in these community events or meetings, and they say, okay, and they start using upstream projects, and then later when they are ready to use it, they can come to Red Hat for those supported products, right? So there's those customers as well. But on the other hand, we also have partners that bring us these customer opportunities because we have, very good foundation products, but we don't really have products that, for example, address the device management capabilities, right? Or analytics capabilities, right? So for those.
Yeah, so what kinds of things do you have? What can, like if you wanted to walk into one of the people that's watching us today and say, all right, what can Red Hat do for you? What kinds of things can you bring to the table?
Very nice. So I think one is what people most know us is kind of, the platform, right? So the platform could be Red Hat Linux, or lately we are seeing a lot of Kubernetes or, containerized orchestration platforms, right? So it could be OpenShift, right? So it could sit in the data center, or it could sit in the edge. Now there are still some features that are being pushed into to make it more edge ready, but there are customers who are deploying it, especially like installation like smart stadiums, where they feel that they have infrastructure to support this, right? So and besides that, we have other products that are targeted towards messaging protocols, right? So your standard messaging broker. Very interesting things. We just announced MQ Streams, which is a Kafka based, right? So it's kind of streaming data support, so which is going to be very interesting because the model is different, a little bit different than how we're supporting the messaging. Usually, as a messaging broker, this is you can log it, you can look back, you can look at the data, you can do the disconnected mode. So it's very
that's
interesting.
That's going to open up some really new
Right,
things, I think,
right.
there too. So, I guess now, how can people learn some more about this? You have some labs. You have some
Sure.
information for them to go look at, and
Sure,
then maybe I don't know if I can we can type it in here or not, but go ahead and share with us some of the things that you brought.
Yeah, so obviously if you go to redhat.com/IoT, you will find a lot of use cases how customers are using it, where some of the products fit, talk about messaging, talk about data transformation products, and sorry, forgot to mention earlier is one of the biggest value customers see is that how to connect the IoT data to the backend system, because in the end you want to have this data coming in from IoT merge with your data from other sources, including enterprise systems, and then get some value out of it.
And that's really where the value is, I think.
Right.
A lot of times, over on the enterprise side, you might even have predictive models running over there, say, it's supposed to be like this, and then I'm looking at the real-time data going, but it's not like that. So then you can start looking at, okay, why? What are the deviations, right?
Right, and I was very impressed actually at Think to see all the AI workloads and the use cases, examples here from customers who are saying, hey, this is what we were doing. We added the AI layer on top, and this is the benefit we get. So that's, I mean, we hear about it, but to see actually live examples, that was very powerful.
This year has been, I think, a big year. I think, first of all, it's been a petri dish. I apologize, my voice being a little scratchy with all the rain and the cold. But it's also been fascinating because I think this year, more than past years that I've seen, been a lot more talk about AI that's implemented and it's actually in production.
Right.
And I think now being able to do things like pushing that AI out to the edge a little bit, you can do quite a bit out there now.
Oh, absolutely.
And move stuff back and forth and look at stuff and run models and run predictions, and it's really going to be fascinating, and it's kind of exciting to see how things are going to progress here in the next few years.
Right. Yeah, because in the end, the value is the insight you get, right? And everybody's talking about connectivity first, like able to get the data in, and then able to connect to the backend systems. So all those problems were there, but I think they are getting solved.
Yeah.
I think what remains is getting the insight out. I think that is the
It's
next
still tough.
study.
I mean, now it's like I've got all this great data. What do I do with it?
Right.
And how do I exploit it? And I think that's still a challenge for most businesses. And I guess some of the good things are they should be coming to an event like Think.
Right.
There's a lot of experts here, both from partners like Red Hat, as well as from IBM, as well as just talking to other clients.
Right.
I was really blown away with some of the stuff I saw yesterday in Jeannie Rometty's speech, with some of the stuff like the Geico was doing.
Right.
That was fascinating.
Yes.
So I'm like, how can an insurance company be that interesting? But it was. It was pretty cool.
Yeah.
And it really can be IoT.
Right.
You look at what they're doing out on the edges, and some of the data they're collecting with their little thingies, the dongle things you stick in the car, and insurance by the mile. Also, there's some really fun stuff that's going on there, and it's fascinating. I just find it all really interesting. So, what do we got? We've got a few minutes left here. So give us a run through maybe of some of the things that our listeners can take a look at and maybe go play with.
Sure. So I put together a little cheat sheet of what me and fellow Red Hatters have been kind of showing off on some of the hands-on labs at Red Hat Summit. Just a plugin for Summit. There's another one coming up in May 2019 in Boston. So if any of you who
be there,
want to
be square.
Be square, make sure you sign up for our lab. They fill up fast.
Are some of these online? Are there some videos people can view as well?
They are actually, and everything is posted on GitHub. So I'm going to give the links.
Make sure we share that with everyone too. Good.
Right. So everything on GitHub, you can try it. And so the main idea here, we talked about the data from the edge coming to some kind of gateway on the edge where a lot of these devices could be not as capable, right? So they bring in the data, the IoT gateway or like intelligent gateway can actually then add other metadata, make it more contextual aware, right? And do a number of things, right? Data transformation, it could, send it from MQTT to the JMS queue, or it can send it to another service.
Yeah, convert protocols. You can maybe even share it multiple directions.
Exactly. So you can do, right. So what?
Turn on the red blinky light. You got to have one of those somewhere.
Right. So yeah. So this is the data transformation, and the labs we kind of did were. There are a number of labs, right? So a few years back, Patrick Steiner, a great essay out of Germany, who's in Google now, had this idea about how to have this gateway, which is soft gateway. So we did this where we actually made this gateway into an actual physical gateway, a VM gateway, like running on a VM, and how to do processing of this data on the edge on this gateway.
That's actually pretty cool because a virtual gateway is even neat too because it gives you a lot of flexibility as far as you don't have to buy a special device. You just got something hanging out on the network. You just blast it onto that and off you go, right?
Yep, absolutely. And then we showed people, right? So the components obviously were Red Hat, right? This is Red Hat focus, but I mean, this could be very well community projects as well, right? So basically, Ansible is the automation engine that provisions the gateway. And then once you have that, you essentially start different components. So the labs go through that. How do you play with? So if you're not familiar with Red Hat products and you want to see how to see them in action, this would be a good lab to to get to deploy these products and then actually build your routes, right? So routes are where you're transforming the data or you're summarizing or doing something with the data, right? So then you can build this camel route and deploy them, and then deploy the rules engine where you can set your rules, right? So for us, it was very simple. And
what would be a rule? Like, what are those things?
So it will be very simple thing like if the data for a temperature is within this range, discard the data. If it's in this range, send it to data center. So this is just the idea. You don't want to send all the data, just some. So what you have is an Excel spreadsheet, or you can have a CSV file, or you can have, now it's a web console where you can actually build rules. So there are a number of, you can have if then, so different ways of putting your rules. And this will kind of, you put the rules in this, and then the rules engine will actually go through and see the data meets these rules or not.
And it can keep up, I mean, it's a high performance
system. High performance, it's a complex event processing, it can do the sliding windows, it can do a number of things.
That's great, that's great. Makes it a lot easier than to do that kind of work.
Right, so yeah, so this is the GitHub site where we kind of talk about, step by step how to do a lot of screenshots, so make it easy. The next one is, let's go back. Next one is the one I did with the great consultant from our consulting team, Andy Block, and where we did this virtual gateway concept, but we said, let's containerize it, right? Because now we are seeing a lot of interest in containers. So we did the same thing where we containerized this, essentially IoT gateway, and then you can deploy it. So now you can put it on OpenShift and you can scale this. So if the gateway is getting bogged down performance-wise or something is happening, you can scale up another one. So
it's just a button click, right?
It's automated actually, because there are health checks, and you say, okay, if this health is degrading, then you spin up another one.
Try and spin up and see if that's, you probably have a if-thens type things in there, right?
That's right.
That's one of the things you can try, right?
Right. Kubernetes can take care of a lot of these things, right? You say if this thing happens, or if the more data is coming in, if more sensors are sending data, spin up another container, right? So spin up another gateway, right? So that's the beauty of scaling on demand that Kubernetes provides. So that was very similar as well, where we kind of build this project where the sensor is sending different kind of humidity data, temperature data, and then we put the the data transformation, and then the rules engine that said, okay, if this is happening, and then we have visualization using Apache Zeppelin, where it showed it and stored it in Postgres.
So if our viewers aren't familiar with OpenShift, what is that in a sentence?
Oh, sure. So OpenShift is downstream of Kubernetes. I hope people have heard of Kubernetes. So it's a container orchestration engine. So what it means is you have your Docker containers you're probably familiar with if you're a developer, right? You use it on your laptop, you have Docker engine doing this. But if you are talking about this, in containers across continents on different servers, then it becomes hard to keep track of which container is running where. If it goes down, do you spin up another one? So Kubernetes allows you to automate this process of massive scale of being able to bring containers up or down, scale them for deployment, and it allows you to do a lot of these things.
And that's what, in real life, that's what you have to do. Sometimes with us as advocates, we just show stuff on our laptops and it all looks really good.
Right.
But when you're actually really doing this for money,
That's right.
you need really powerful kind of things like this.
Right,
Right.
and that's why we are seeing a lot of adoption in the market for Kubernetes and obviously OpenShift.
Sure,
right?
yeah, Kubernetes is hot right now. Yeah,
Right,
yeah, yeah.
because people feel that because containers is hot, and as people try to deploy it in production, they feel that they need something that will
They
allow
need
them
help
to.
with it. Well, part of it's that. It's just, it's hard.
It is
It's
hard
really
to do.
complicated, yeah.
Right. So yeah, so this was done on OpenShift, and was same thing, right? The flow of how you will deploy it. So if you're new to Kubernetes and you like to deploy, you want to see how to build a Kubernetes application, try this project.
great lab, okay.
It's a great lab where it walks you through. This is what the application is. This is how you build a project. This is how you deploy it. This is how you change it. This is how you do it dynamically. So if you configuration changes, the container will actually spin down, spin up again, because it knows configuration has changed, and launch with a new configuration. So a lot of cool features that Andy has put into this. And then again, the GitHub for this is over here, right? So it's a OpenShift example project, right? That talks about this. And then you had talked about earlier what Red Hat is doing in terms of solution-wise, right? So we are going to market with our partners, and one example would be this end-to-end IoT project, right? So where we are. If I have it. Yeah, so this kind of, this one is it. This one talks about how you have telemetry data coming in for devices. This is more of an Industry 4.0 scenario, where you have this IoT gateway running on the edge, and this has, I was talking about this edge analytics capability. So this is where partner Cloudera does machine learning, and they have decision framework here, and they do the data models here, get the learnings, and then push these data learning into these models here on the gateway, right? So they could actually monitor data real time and then take action there.
Right, okay.
And then there is a site that talks about, if you're interested, how to set up this demo, right? So this demo.
That's great. And I can see that a lot of our viewers, same kind of thing, they're struggling with Industry 4.0 stuff.
Right.
A lot of our people are in manufacturing, a lot of our clients, a lot of our friends.
Right.
Good stuff. That's really interesting.
Awesome. Yeah, so it's pretty exciting stuff. And in fact, Andy and I and a bunch of other Red Hatters are doing another lab on this summit. So, check it out.
Great. That's fantastic. Well, let's wrap it up for the day. Or not for the day, for our spot.
That's right.
I don't want to. Does everybody stay where you are? Coming up, otherwise Spencer will kill me, because coming up with Spencer is actually, we're going to talk some more about Kubernetes, and I think I might have scrolled it away here, but it's how to. I've lost it.
It's Helm.
2, 3, 4. It's just with Helm. Yes, I think I've scrolled.
Oh.
I don't know. It's off the screen here, but it's Kubernetes with Helm, and how we can do some work there, and that's also pretty interesting stuff. Same thing, scheduling it out in the wild and in the large applications. So, Ishu, thank you very much.
Thank you, Greg.
It's great having you here.
Pleasure.
Thanks for being on with us.
Awesome. It's good
Thank
to
you.
hear. Thank you.